Somebody once asked me, how many multimeters do you need? Well, all of them, obviously. Hey, what's happening, guys? Today we got a twofer. This is going to scratch 2 itches with one finger. It's both an oscilloscope and a multimeter. This is the Mustool MDS8207 Intelligent Digital Storage Scope Meter, 40 megahertz, along with a multimeter. And this was kindly sent out to us free of charge from Banggood for our consideration. So I want to thank our friends at Banggood for making that possible. And we'll take a look at it on their site at the end of the video. This is currently listing for $89.99. So inside the box we've got our user manual. We've got the device, a nice carrying bag, a set of leads, and a K-type thermocouple. Pseudoblah for quickly measuring air, odd gas, and not liquid. I think they probably mean suitable for quickly measuring air and gas and hot liquid. If it's not good for measuring not liquid, I don't know what we would do with it. So here's the meter itself. I would call this a medium-sized meter. Here's a full-size fluke meter for comparison. And it's very light. And it uses 3 AA batteries. I prefer meters that use AA batteries. They just have a higher energy density than 9-volt batteries. We've got some function keys and an R and an S button. And if we look down here at the ports, we have our common, then we have our main voltage / temperature reading port, and we have a separate port for the oscilloscope, along with a separate port for reading current. And then up here we have a transistor measuring device. So we're going to check this all out. Now, as we do with all multimeters, we measure them using the same set of probes. These are the gold-tipped ProbeMaster probes. I'm explaining this, but we use the same probes on all meters so that we eliminate the variable of different probes. And we're only testing the meters. So if you want to go back and look at different meters I've tested, you can know that the leads have absolutely nothing to do with the accuracy or measurements, because we've eliminated that by using the same leads in every video. I await your angry comments. So let's get that stuff out of the way, and we'll take a quick look here at some specs. I'm not going to read them. You're welcome to pause the video and go through that. Okay, so this has a nicely reverse backlit screen, which looks good here. Camera doesn't quite capture it that great with the bright lights on, so I'll turn off the bright overhead lights and you'll be able to see it much better like this. Alright, let's say we start out with some resistance measurements. You can see here, especially if we zoom in, we've got our capacitance, resistance, diode, and continuity all on that function. I like that. That makes it nice. So we'll set that guy up there. And we'll bring in this little decade board. People always ask me, where do you get it? You can get it anywhere, but it's available in my Amazon shop. Okay? There is a link to that down below. Let me put a couple leads on there. There we go. That way we don't have to worry about shorting it out. Alright, let's start with 1K. Come on. Yep, very close. And how about 5K? Yep. Let's try something low. Let's do 10 ohms. Maybe 10.5. Let's try 3 ohms. Reading a little high on the low end. Let's see how it's doing on the high end. 1 meg. Yep. 9 megs. Very good. Very, very good. Alright, let's bring out the precision resistance standard. By the way, this is a 6,000 count meter. Just thought I'd share that there. 10 meg ohm resistance. So here's our little standard. And 179.5K. $179.9. I mean, it's fine. It's right in the ballpark. There's no worries there. Alright, let's have a look at some capacitances. This nice chocolate drop should be 3 nanofarad. You're locked on there. Oh, 3.093. Close enough. Should be a 10 microfarad. Yep. What do we got here? 470s, I think. Yep, 470. Come on. Pretty good. And 220. These little hooks don't want to grab very well. Maybe it's too early for them. It's only 8 o'clock in the morning. Okay. So it's well within its accuracy rating. So we can check this on the precision block, 59.77 nanofarad. See how that does. The thing about capacitors is there's huge manufacturing tolerances on them, so they're never as accurate as you think they are. 59.77, 59.79, yeah. I mean, it's perfectly accurate. There's no trouble there whatsoever. Alright, what do you say we look at some diodes? Have a selection of them right here. So we'll hit our select mode, resistance, diode mode. Now it says the open circuit voltage for diode testing is 3 volts, about 2 milliamps. So we can start with the red. So I get everything in the picture. Oh, backwards. Try again. There we go. It's lit. 1.8 yellow. white, green, blue. It's doing great, lit them all. This is a Schottky, so there we are, 0.2, and a standard silicon junction, which should be about 0.6, somewhere in there. Yeah, there's no worries with this thing whatsoever. Everything looks absolutely within spec, which you would expect for a modern meter where everything is basically controlled on a chip. It's not like the old days where you had to have, you know, lines of resistors and everything had to be perfectly measured out to the, you know, 1/10 of a millimeter in wire length. Alright, next up, let's say we test the current reading capabilities. Now, you know, in my last multimeter video, my current source died, so I'm whipping together this little board here. Let me do different current readings. Right now I only have the blue part wired up, but if what we do is we put our positive in here, our ground here, and we can read the current here. At 5 volts we should get 0.52 milliamps, and at 10 volts 1.5 milliamps. So hook positive there, hook the negative here, and then we can read right here, so we're in series. Okay. Oh. There we go. So there's 0.51, and we'll take it up to 10 volts. There we are at 10 volts, 1.56. So yeah, reads low current stuff really good. Excellent. We say we check out a transistor. I'm sure I got some in here somewhere, right? Here we go. 2N3906. I think that's a PNP transistor. We'll find out. Turn that off. Pull out the leads. Spread the feet out a little bit. Put them in the NPN. Go to our transistor reading. Nothing. Maybe it's upside down. Try the other one. Huh. Okay, let me find a different transistor. What we got here? I think these are 2222s. Come on, fingers. No, these are 8 something. Oh. Yeah, our chances of focusing on that are slim to none. Have to get out the opto visor for this one, I'm afraid. And some light. MST2N6027. I don't know what that is. It is an NPN transistor. And let me see the pinout. I think it's the emitter base collector like this. Nothing. Huh. This is odd. Well, I'm guessing that doesn't work. That's unfortunate. So, if the multimeter portion of this can be considered dinner, then let's go on to dessert, which would be the oscilloscope portion of the evening. Now, let's just get a couple things out of the way right quick. This isn't Baked Alaska. This is more like a Little Debbie brownie. Nothing wrong with the Little Debbie brownie. They're good. They're delicious. They're chocolatey. So, what I'm saying here is this a replacement for your Regal 1054Z? No, absolutely not. But, is it a useful scope? Yes. I think it really is. If we look at some of the specs on it, has an analog bandwidth of about 40 megahertz with 8 bits of vertical resolution and only one channel. Nonlinearity is plus or minus 1 bit, and it has auto, single, and normal trigger functions. Now, your oscilloscope probe goes here. So it's just going to use your regular multimeter probes. Which, yeah, I don't know how you feel about that. I'd rather have a regular multimeter or oscilloscope probe, but we don't get it today. Alright, so here's our Little Debbie in the form of a couple of circuits. First of all, we have an Arduino over here running just a little PWM script. You can see it ramping up that light there, up and down. So I'll show you how easy this oscilloscope is to use, which is what I think is one of its great features. I'm going to attach the ground lead down there. And we'll attach our signal lead here. And now if we come over here, zoom in on the meter and just hit the R button, you can see we have our PWM signal. And if you zoom in there, you can see our frequency is 490 or so hertz. You can see our voltage peak to peak, our voltage average, and our voltage RMS. So, like I said, I do think this is a very useful little device. You're not going to align your radios with it. But then, hey, you knew that going in, didn't you? Alright, I'm going to take the clippy clip off of here. I'm going to turn on some more light so I can see what the heck I'm doing. So here's a simple 555 circuit. Come up on that. Zoom in here so you can see. And once again, I'm just going to press the R. And there's our waveform. What's our frequency? 48.5 kilohertz. Then I've set up a first order low pass filter here. You can come over here and you can see it respectfully captures the waveform. So, you know, there's no worries there whatsoever. Now, let's take a look at the clock on the Arduino, one of the clocks. Come over here. Grab a look at that clock there. So what I'm going to do is I'm going to take my ground lead and I'm going to bring it over here and put it into one of the ground connections. I have this lead here. I'm going to come over here, hit the clock, hit the R button, and there you can see we got our 16 megahertz clock signal. So it is absolutely useful. It will even save some of the waveforms, which is nice. Let's take a look at this on Banggood's website. Alright, here we are on the website on banggood.com, and I'll put a link to this down below. You can see over here, this is the upgraded Mustool MDS8207, blah blah blah, and it lists for $89.75. $2.99 standard shipping. Total price $89.75. There's a couple of reviews in there in Espanol. When we come down here, you can get a look at some of the specs. So it will save 100 datas or 50 waveforms. I don't know what datas are, but it'll save them. Again, I think it's very nice. It is a nice, useful meter, and it is a utilitarian single-channel scope. So I've got no problem with it whatsoever. All right, again, there'll be a link down below, or you can check this out and get one if you see fit. Again, I just want to thank Banggood for sending this out to us. I want to thank you all for watching and spending time with me today. A community like this is something that we can all be very proud of. So again, thank you very much for all your support of Learn Electronics. Please feel free to check out the Patreon page. $1 a month is all I ask, and really helps keep the channel alive. We also have an Amazon shop where you can buy most of the items that you see on here, and there's a link to it down below.